So, good morning, students. Today, we are going to learn an important concept in the chapter Real Numbers of ninth class, that is, Law of Exponents for Real Numbers. Good morning. And we have to go with a discussion that laws of exponents for real numbers. Exponents, we can go with what is an exponent. We are, all of you know that exponent is nothing but here. Previously, we have learned in your 8th class exponents and powers. There is a slight difference between power and an exponent. Just I will explain that and I will go to this topic. If you go with 2 to the power of 5, see, this one is called fifth power of 2. This is notated as fifth power of 2. It can be read as fifth power of 2. Whereas 2 is called base and 5 is called exponent. So I think you may understand the difference between here the exponent and power. Power cannot be written as power. Generally, so many are saying that power is 5. No, it's not power is 5. 2 power 5 total is known as fifth power of 5, fifth power of 2. That means 32 is nothing but fifth power of 2. So power, మనం క్లియర్గా పవర్ని సెపరేట్గా చెప్పలేము, పవర్ ఆఫ్ సంథింగ్ అని చెప్పగలం. సో పవర్ ఆఫ్ ఫిఫ్త్ పవర్ ఆఫ్ 2 ఈజ్ 32. సో ఫోర్త్ పవర్ ఆఫ్ 2 ఈజ్ 16. థర్డ్ పవర్ ఆఫ్ 2 ఈజ్ 8. Like that you have to say. But if you go with exponent, we have to see how many times that number is multiplied. So 2 power 5, 2 is multiplied 5 times. 2 doesn't multiply with 5. 2 is multiplied 5 times. So that's why 5 is known as exponent. So in your 8th class, you have studied about powers and exponents when the exponents are integers. All the exponents are integers. So now we extend that loss, whatever we have learned, to rational numbers. Today that's topic we are going to learn, and just we will review the things what we have learned in exponents previous in 8th class. So the formulas is a power m times a power n equals to a power m plus n, and similarly a power m divided by a power n is equals to a power m minus n, where m is greater than n, and then a power m whole power n is equals to a power mn. And finally, you have two more. A power minus n is equals to 1 by a power n, and a power 0 is equals to 1. And product and division formula, ab whole power m equals a power m into b power m. Similarly, a by b whole power m equals a power m by b power m. These are the laws of exponents for any, either rational numbers or integers. Now we will check whether it is applicable for rational numbers or not. Here one condition is very important. Here a should not be equal to 0. And for a power m minus n also we have 3 cases actually. Where m greater than n, you will get m minus n. Where m is equals to n, what happens? M minus m, it will become 0. A power 0, a power 0 will becomes 1. So this is second condition. And final condition is if m less than n, what you will get? If m less than n, this you will get the reciprocal as 1 by a power n minus m. So subtraction always in the exponent should be done from big number to small number. Hence, if n is, if here n will be greater, therefore I have to write 1 by a power n minus m. Now I am checking all these are applicable for rational numbers or not. All these formulae are applicable for rational numbers or not. I am checking that. For this, just we will go with some questions over here, examples that they have given in the textbook. See, 2 power 2 by 3 into at the same time 2 power 1 by 3. So can we finish this 2 power 2 by 3 into 2 power 1 by 3? The same we will apply as a power m into a power n. So I can go with 2 power 2 by 3 plus 1 by 3. So here you will get 2 power as bases are equal. So 3 by 3 I will get. So 2 power 3 is 3 by 3 is 1. Therefore we will get 2 as 1. So this is one thing. And second application I can go with 5 power 1 by 7 whole power 4. So this is in the form of a power m whole power n. So it will be a power mn. So 1 by 7 into 4. Therefore I will get 5 power 4 by 7. This is another application. So next, and if you go with the a power m into a power n, a power m whole power a power n, and one more a power m by 3 power 1 by 5 they have given, and divided by 3 power 1 by 3. This you can apply as a power m by a power n as 3 power 1 by 5 minus 1 by 3. Here you know how to do this fractions to like fractions, so that I can change it as, so I will get 3 minus 5 by, you will get 15. So LCM will be 15, and 3 ones are 3 minus 5 ones. So I'll get 3 power minus 2 by 15. There you can apply again a power minus n as 1 by a power n as 1 by 3 power 2 by 15. Just I am introducing. I will explain in detail with some problems, just examples. So if you observe all these, here the exponents are changed as rationals. Previous classes you have learned exponents as integers. So even for rational numbers they are applying. So whenever you write the formula for all those, a power m into a power n or a power p into a power q, anything, now onwards you have to mention compulsory as, for example, I am explaining with one formula, a power m into a power n as a power m plus n you have mentioned. For this, what you have to mention conditions, a should be greater than 0, a should be positive, and mn should be rational numbers now onwards. Previously, we have mentioned only integers, mn can be integers. Now extension, we can go with rational numbers. Now I can go with some another important concept which we are going to learn here. One thing is, just observe carefully. So many times 3 square is equals to 9. So many students are writing, what will be the 3? What will be the notation of 3? What you will say? 3 square equals to 9 implies 3 equals to, how you can write? So many are writing. So for example, maybe you can answer this. X square is equals to 9. So many will say x is equals to, what is x? What we can say as x? 3 square equal to 9. 3 equal to, yeah, x square equal to 9. X is equal to what we will mention? Okay. So x generally, so many will say that square root of 9. And 3 is equal to square root of 9. So now my question is, yes, my question is, how you say that square becomes square root? How do you know that if the square becomes square root? How can you say that square, if x square equal to 9, then x is equal to root 9? How you can justify your answer? So here, once you observe that x square is equal to 9, generally what happens here is x square is equals to 9. Now I want x. To want x, what I have to do is, I have to raise this power to some extent so that I will get x. So how much extent I have to raise that power? As it is 2, that 2 should be cancelled. I have to raise this power to 1 by 2. That is equals to, here also I have to raise that power to 1 by 2. Hence here I can apply, here I will apply a power m whole power n formula. Then a power mn I will get 2 into 1 by 2. Here I will get 9 power 1 by 2. So that these two will be cancelled. Now I got x is equals to 9 power 1 by 2. Generally, in general, we will say that if square goes to that side, square root. If cube goes to that side, cube root. Why? How that square becomes square root? Why? Square does not move any side. And transposition also, so many things we will take it as granted. Why? Because x plus 2 is equal to 7. If 2 takes to right hand side, if 2 transposes to right hand side, we will not take to any side. The general process is we will subtract 2 on both sides, because I need only x, so that I have to subtract 2 on both sides. 2 on both sides subtract చేస్తాను కానీ 2 అటు వెళ్ళిపోదు. ఎందుకు వెళ్ళిపోతుంది అలా? నన్ను ఎవరైనా తిట్టారండి. It will not go that. So here also the square does not go anywhere. Square ekkadiki velipodandi. Square remains the same. But what we will do is that square, I need the value of x, so that that square should be removed. But removing in the nothing but I have to raise that power to somewhere. To understand, I will give you one more example. For example, x is equals to 2. You will do this always. Cubing on both sides. Cubing on both sides means what you will do? So x cube is equals to 2 cube. Why? Because I need to raise the power x to 3. Hence, this will be the cube. Similarly, I need x here. So I want to cancel 2. To cancel 2, I have to raise that power to 1 by 2. So both sides 1 by 2. Hence, I will get this 9 power 1 by 2. So 9 power 1 by 2 is exponential notation. ఎక్స్పోనెంట్ ఉంది కాబట్టి ఎక్స్పోనెంట్ కింద రాసాం కాబట్టి ఎక్స్పోనెన్షియల్ నొటేషన్ అంటాం. దానికి సింబాలిక్ నొటేషన్ ఈజ్ అనదర్ సింబాలిక్ నొటేషన్. ఎక్స్ ఈజ్ ఈక్వల్స్ టు 9 power 1 by 2. Symbolic notation is square root 9. This is the symbol. Hence, this is the symbol. That's why we can say that, we can say that this is square root 9. Yes, that's good. So square root 9 is the symbol. 9 power 1 by 2 is the exponential form. One more doubt here we have. If you go with x cube is equals to some like 8, then what will be the x? The same, you can say now the answer, x is equal to 8 power 1 by 3. As here 9 power 1 by 2, here x will be the 8 power 1 by 3. So this notation of the symbol notation of 8 power 1 by 3 is nothing but cubed root 8. This is known as cubed root 8. A cubed root 8 denotes that in exponential form 8 power 1 by 3. Remember very carefully. Here one more doubt is there. For every number, for cubed root or fourth root, for example, if I go the next, x is equals to some x power 4 is equals to 16. Then x will be 16 power 1 by 4. The notation with symbol is fourth root 16. So many will have the doubt that, sir, for cubed root we will write 3 here. For fourth root we will write 4 here. But why the square root doesn't write, we are writing 2 here. So generally in a notation, definitely I have to write 2 here. Definitely I have to write 2. That's why this is the second order. This is the third order. This is the fourth order. But in general we will say that square root. In మన నోట్తో స్క్వేర్ రూట్ అనేస్తున్నాం కాబట్టి ఇంకా 2 మనం మెన్షన్ చెయ్యం. ఇక్కడ క్యూబ్ రూట్ అంటున్నా మనకు నొటేషన్లో కనబడాలి కాబట్టి క్యూబ్ రూట్ అని మెన్షన్ చేస్తాం ఇన్ జనరల్. బట్ బేసికల్లీ యాజ్ పర్ రూల్ ఐ హ్యావ్ టు రైట్ 2, 3, 4 like this only. And I hope all of you understand that how this square becomes square root on right hand side. So a square doesn't move anywhere, just its notation changes into 1 by 2. So if I go with the numbers, if I remove the x and if I go with the numbers, once what I will get here, see 5 square equals to 25. Then 5 square equals 25, 5 becomes 25 whole power 1 by 2. So how can I justify that? The 25 power 1 by 2 will be 5. So I can write 25 as 5 square whole power 1 by 2, and it's in the form of a power m whole power n. Then I can go with 5 power 2 into 1 by 2. Both 2 will be cancelled. Hence I will get 5. So you can ask me, sir, why you are explaining all these in detail like this? One thing I am trying to explain you that if it is a rational exponent also, we can find the value. Generally, if I go with 5 square, everybody knows that 5 square, I can show that, sir, I can say that 5 is multiplied 2 times. But 5 power 1 by 2 or 25 power 1 by 2, how you can explain? Can you say that 25 is multiplied half a times? మనం హాఫ్ ఏ టైమ్స్ మల్టిప్లై చేయలేం కదండి దాన్ని. మరి 25 పవర్ 1 by 2 ఏం రిప్రజెంట్ చేస్తుంది? దట్ ఈస్ అవర్ క్లాస్ టుడే. What does the 25 power 1 by 2 explains? So 25 power 1 by 2 is explains a real number. It's also a real number. It's a real number which equals to 5 here. 25 power 1 by 2 is a real number which equals to 5. But you cannot explain this with the basic definition. మనకు basic definition తో I cannot explain. Yes, 25 power 1 by 2 can be written as square root of 5. That's right. Square root of 5, that is equal to 5. That's okay. That's what I'm saying. Generally, 25 power 1 by 2 with the definition as 5 square is equal to 5 into 5, 5 cube equal to 5 into 5 into 5. You cannot explain this. 25 power 1 by 2 can be explained as, it's nothing but square root of 5, that is symbol. Square root of 5, square root of 25, that equals to 5. How you got that is like this. You can explain. That means I have used all rational exponents here by applying the laws of exponents. As laws of exponents ఎందుకు నేర్చుకోవాలని దాన్ని చెప్తున్నాను. ఆ లాస్ ఆఫ్ ఎక్స్పోనెంట్స్ యూజ్ చేసి ఐ హ్యావ్ డన్ విత్ 25 పవర్ 1 by 2. అయితే సార్ మీరు 25 పవర్ 1 by 2 అంటే వీ ఆల్రెడీ నో దట్ ఈస్ స్క్వేర్ రూట్ ఆఫ్ 25 ఆర్ 8 పవర్ 1 by 3 రాసిన 2 క్యూబ్ ఈక్వల్ టు 8 మాకు తెలుసు సార్. అయితే ఇందులో కొన్ని ప్రాబ్లమ్స్కి మరి ఇప్పుడు అన్నిటికీ మనం ఎక్స్ప్లెయిన్ చేయగలమా? ఫర్ ఎగ్జాంపుల్, ఇఫ్ ఐ గో విత్ ద సేమ్ 25 హోల్ పవర్ 1 by 3, కెన్ యూ సే వాట్స్ ద వాల్యూ ఆఫ్ దిస్? సార్ మీరు అన్ని రియల్ నెంబర్స్ అంటున్నారు. యూ మెన్షన్ ఆల్ దీస్ ఆర్ రియల్ నెంబర్స్. ఓకే, వాట్ అబౌట్ 25 పవర్ 1 by 3? If it is 16 power 1 by 2, sir, we know that that is square root of 16. I will get 4. If you give that 8 power 1 by 3, that is nothing but cube root of 8, sir. So this can be written as, again, 2 cube whole power 1 by 3, sir. So 3 will be cancelled. I will get 2. Already square root and cube root, I know that. But what about 25 power 1 by 3? Yes, 25 power 1 by 3 notation is exponential. If you write in symbolic form, this is cube root 25. Can you say what is it? What's that number? Is it real number or not? Is it real? Yes, it is real. If it is real, definitely they have only two families, either rational or irrational. So it comes under rational or irrational. Definitely everybody says that it is not rational. It will be irrational. But what's the definition of irrational? The non-terminating, non-repeating decimals are irrationals. But can you find the value of cube root of 25? Can you say how you can find the cube root of 25 in decimal form? So we have that. That's the irrationality. Have that stuff. For the remaining numbers, we have rational numbers and all clear definitions, and we can applications are very simple. Whereas we'll go with irrationals. It's a different types of irrationals. We have learned two types of irrationals already. One is neither terminating nor repeating decimals. Simple definition will say, or which are not in the form of p by q. We say already we done that. Root 2, root 3, root 4, root 5 we have done previously by doing in previous classes by doing the square root method, perfect square root method. We have find they are not terminating and not repeating. Hence those are irrationals. But what about this type of things? So they have another types of things. Those are irrationals only, and those irrationals are named as surds. Irrationals ki inko పేరు ఏం చెప్పారంటే surds అని చెప్పారు. We'll go with the definition of a surd. Definition of a surd కి మనం ఇప్పుడు నేర్చుకోబోతున్నాం. ఆ definition of surd కి వెళ్ళే ముందు just ఈ exponents rational number అయినప్పుడు how to convert them into real numbers, rational numbers అనేది ఒక ఎగ్జాంపుల్, మీకు ఎగ్జాంపుల్ 19 ఉంది దట్ ఐ హ్యావ్ డన్ ఆల్రెడీ. మీకు స్టార్టింగ్లోనే క్లాస్ స్టార్టింగ్లోనే ఫినిష్ చేశాను. జస్ట్ యూ గో త్రూ దట్. అది చూసి మీరు డూ దిస్ హోంవర్క్ చేయండి. టుడే యువర్ హోంవర్క్ విల్ బి డూ దిస్ ఇన్ యువర్ పేజ్ నెంబర్ 23. So this you have to do and send it to me and I will check it. And if now we are going with another definition here. Before going to the third, I will now what we have discussed already there, we will conclude here. A power n is equals to b. Then what happens about a? A is equals to b power 1 by n. Simply we can write nth root b. A is equals to nth root b. This notation you have to register in your brain first. I am repeating again. A power n is equals to b. Then a becomes b power 1 by n. I have explained you how that n becomes 1 by n on that side in the beginning. So similarly, directly you can write that a is equal to nth root b also. You can write nth root b or b power 1 by n. So here the what will be the conditions generally? A can be any real number. That will be the first condition. A can be any real number. Any real number means we have only two, rational or irrational. So for irrationals also I can go with this. So A can be any real number and A should be positive and n should be positive. Positive real number and n should be positive. I can go with real number itself. Why can't? I will check that. So A can be real number, positive real number, n can be any positive real number if I take. Then what happens is n, if n is irrational, I cannot. This is rational, I can. But if n is irrational, I cannot. 25 whole power root 2, I cannot. So n should be a positive rational. This is the thing where we can apply here. You can ask n number of doubts on this. I definitely will explain. You can in comment section or in my WhatsApp group. You can. This is very important because mathematics is a subject where the students applies logic and questions. More number of questions and more number of doubts leads to the concrete subject. So not doing the problems well. So asking the doubts, thinking more. A power n equals to b and a equal to b power 1 by n is the general notation of real numbers. Now I am explaining you one more topic, that is third, which is another form of a rational number clearly. Once you have to listen very, very carefully here. First I will explain with numbers and then it leads to the definition. Once you observe, I will go with 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Except 1. So 1 should not be taken. That is the first condition. 1 should not be taken. And if you take 2, once you observe, this is a rational number. This is a and real number, positive rational number. This is a positive rational number. A positive rational number which cannot be expressed as nth power of other positive rational number. I am repeating. A rational number which cannot be expressed as nth power of other rational number. Other rational number is very important. 2 can be written as 2 power 1, but it's not other. So if I want to listen, if I want to explain 2 as power of second power of any other rational number. I want to explain 2 as second power of other rational number. Is it possible? There is no number which can be second power of other rational number leads to 2. So 2 ni nenu veroka number square kinda nenu raayalenu. I cannot. So then what happens? That x becomes 2 power 1 by 2, which is in the form of square root 2. And 3, if I want to 3 as some fourth power of any other rational number, I cannot write. So then x becomes 3 power 1 by 4, that is 4th root 3. But if I go with 2, 2 can be written as square of other rational number. I know. So it can be written as 2. So the 2 is equal to 4 power 1 by 2 square root of 4. This is rational. If I go with 5, 6, 7, same. If I go with 8, I want to explain this clearly for you. Why? Because I cannot write the square of any other rational number. Hence, square root of 8 is third. But I can write this one as 2 cube. So 2 is equal to 8 power 1 by 3, that is cube root 8 is not a surd. You may get understand this the logic over here. Square root 8 is surd, but cube root 8 is not a surd. Why? Because 8 can be expressed as cube of other rational number. That's the definition of a surd. If a rational number cannot be expressed as nth power of other rational number, then nth root of that number is a surd. Very simple. Just you concentrate on that. If a number cannot be expressed as nth power of other rational number, then nth root that number is called a surd. So, if here square root 2 is a surd, square root 3 will be surd. Just you imagine why sir is mentioning that root 3 is a surd. Immediately, what idea you should get in your mind? Square root 3. Yes, 3 cannot be expressed as square of another number. 3 cannot be expressed as square of another number. 3 ni inkoka number square kinda rayalemu. So that square root 3 is a surd. 9 cannot be expressed as cube of another number. 9 ni veroka number ni cube cheste 9 radu. Hence cube root 9 is a surd. 9 can be expressed as square of another rational number. 3 is 3. So square root 9 is not a surd. These the lines you have to think in your mind so that you can understand the surd well. So now we will go with the definition of a surd. A is a positive integer greater than 1. A should be greater than 1 because we didn't take 1 here. And a positive rational number A which cannot be expressed as nth power of other rational number, then we can say that nth root A is a surd. Nth root A is a surd. So that's the definition they have given. N is called order. So if I write square root 3, it's a second order surd. Cube root 3, third order surd. Like fourth root 3 is the fourth order surd. This is the thing. This is the way we have to represent the surds. Surds are irrational numbers only. Surds are also irrational numbers. Every surd is a rational number, but every irrational number is not a surd. Remember, every irrational number need not be a surd. Every surd is an irrational number. You can give me the example. Why? You can think and you can give me the example. Now, here, this nth root A is called radicand. Another form, a radical. This is called. And this nth root is called radical sign. And n is called order of the surd. So this is surd. I think all of you understand what is a surd, how we can define a surd. A is a positive rational number and n is a positive integer, and if A cannot be written as nth power of other rational number, then nth root A is called a surd. I am repeating finally, A is a rational number and which cannot be expressed as nth power of other rational number, then nth root A will be the surd. So form of the surd is nth root A. I already explained how you can change from surd to exponential form. If you go with cube root 4, this is the surd form, radical form. This is known as radical form. And if you want to express into exponential form, you can write this one as 4 power 1 by 3. So converting radical to exponential, that you have do this in the page number 24. You have to go with the two problems. Radical to exponential, exponential to radical. Radical to exponential already we have learned. Cube root 4 is equal to 4 power 1 by 3. And exponential to radical, if you go with 4 power 1 by 3, I can write how the denominator should be the order of surd and the base should be base and numerator will be the power of the number. For example, if I written with 5 power 2 by 3, how I can write in radical form? The denominator should be the order, cube root, and base will be the base, and the numerator will be the power. I am giving you one more example. 6 power 7 by 2, if you want to write. So this is, we know that, exponential form. Converting into radical form, this will be the order square root and 6 power 7. If I want to convert reverse, that means they have given some fifth root 5 power 3. So that you have to write 5. This will be the base and order will be the denominator and exponent will be the numerator. That means if I write nth root a power m, what I have to write? First a I have to write, and this n will be the denominator and the exponent will be the numerator. This is radical to exponential and exponential to radical. So you practice well and complete your do these problems here. And then, yes, one question they have given interestingly in the textbook. Can you write square root of 2 in radical form? In exponential form. This is radical form. Can you write square root of 2? Yes, I can. How? So first I have to write that square root of 2 as it is, and this will be 2 power 1 by 2. Is it? Square root 2 is 2 power 1 by 2. And here 2, square root 2 means 2 will be there. So this can be written as again 2 power. Here the power will be the numerator and this will be the denominator. So what I will get again? 2 power 1 by 2 into 1 by 2. So that I will get 2 power 1 by 4. This is one method. And another method also there, how we can say that square root of 2 in exponential form, if I write 2 power 1 by 2 whole power 1 by 2. And this is a power m whole power n. A power m whole power n will be a power mn. So 1 by 2 into 1 by 2. Then I will get 2 power 1 by 4. So this is the surds. So I am mentioning that why we have taken the surds and laws of exponents. Laws of exponents leads to learn the definition of the surds. So what is a surd? It is an irrational number again. It's a real number. So the extension of the surds and the application of surds will be in your next classes. So that definition is very important and you understand. If you have any doubts regarding the definitions and all examples, just you can comment, or otherwise you can send me through WhatsApp. So finally I'm explaining one more the definition again. A rational number which cannot be expressed as nth power of other rational number, then that nth root of that number will be the surd. So just, dear students, just you complete the do this again in page number 24 also. And in exercise already you have finished some problems. Up to 4 you have finished, I think so. Remaining 4 to remaining problems, whatever you can finish, you finish. That means today class helps you to finish the problem number 8 even, and 9 and 10 definitely we will try. Just you try. If not, I will conclude that by tomorrow in next class. So in next class I will complete this chapter, and one day I will give you the for preparation, and definitely you have an online examination on this chapter. So prepare well, stay home, stay safe, keep learning. Wish you all the best. And all of you who have attended today, all of you very good. You have a good number, and welcome. 2 more members today joined, Chinmay and one more, Srinivas and yes, Amruta and all, and as well as Prasanna, Yashashvi and all. So very good, very good. Anjala Javeri, yes, keep on doing good. All the best. Thank you. Thank you.